Since its discovery, the planet of Uranus has got scientists deeply curious. It is a planet unlike any other in the solar system. The only spacecraft to pass by it was Voyager 2. No spacecraft has ever orbited this far-off planet to conduct extensive up-close research on it. This is the only reason we know about Uranus more than simply where it is and what it looks like. But it's not enough. We don't know about it nearly as much as we know about Mars and Mercury. Professor Lee Fletcher of Lancaster University has said, "There are few places left in the solar system about which we know less than we do about Uranus. The inner planets have been visited many times, and so have Jupiter and Saturn. Even tiny distant Pluto has been surveyed. So a Uranus mission will fill a glaring gap in our knowledge of the process that shaped our solar system." This is why NASA recently announced a mission to reach Uranus by 2049 to find out all we can about the planet. Our story started a long time ago. On March 13, 1781, Sir William Herschel discovered the seventh planet while searching the night sky for comets. At first, he believed he found another icy body. When the time came to suggest a name, he suggested calling it Georgium Sidus, or George's Star, after his patron who funded his studies, King George III. But outside of England, not many people liked the name Herschel. Named after its discovery was also proposed. Uranus was ultimately given the name of an ancient Greek sky god by German astronomer Johann Elert Bode, whose observations helped to confirm the new object's status as a planet. After Uranus was discovered, it was still largely unknown due to its extreme distance from the Sun, as it is twice as far away as Saturn. Since Uranus's axis of rotation is nearly perpendicular to its orbital path, and it takes the planet 84 years to complete one revolution around the Sun, the planet is essentially lying on its side. Astronomers didn't find 5 faint rings orbiting Uranus until March 10, 1977, just 6 months before the Voyager spacecraft departed Earth on their historic journeys of exploration of the outer planets. The discovery was made using NASA's Cooper Airborne Observatory as Uranus passed in front of a far-off star, and the star's light was diminished as it passed behind the rings. In the third of its 4 planetary encounters, the Voyager 2 spacecraft came within 50,700 miles of the tops of Uranus's clouds on January 24, 1986. Voyager 2 learned a lot about Uranus during its 4 months of observation, including details about its atmosphere, distinctive moons, and oddly tilted magnetic field. This is where we currently get our knowledge of Uranus from. But why is going to Uranus so important? The search for extraterrestrial life may benefit from a comprehensive Uranus mission. The National Academies describes the planet's largest moons, Miranda, Ariel, Umbriel, Tatiana, and Oberon, as potential ocean worlds similar to Europa, which is one of Jupiter's moons. The planet Uranus is extremely cold, really cold. The clouds are composed of ice crystals made of ammonia and methane, and their average temperature is minus 315 degrees Fahrenheit. Recent research has revealed that the planet's average temperature is freezing minus 353 degrees Fahrenheit, and wind speeds on Uranus range from 90 to 360 miles per hour. The lowest temperature recorded in Uranus's lower atmosphere is minus 371 degrees Fahrenheit, which is comparable to Neptune's extreme cold. Hubble observations show that clouds travel over 300 miles per hour around Uranus. At minus 387 degrees Fahrenheit, Pluto is only marginally colder than Uranus. That brings us to Uranus's candidacy as a great tool for studying ice giants, something that scientists have expressed. The 2 ice giants of our solar system, Uranus and Neptune, which NASA described as primarily consisting of ice, have yet to receive a dedicated mission. A better understanding of ice giants is crucial given the growing interest in exoplanets, planets that orbit stars other than the Sun, of which about 5,000 have been found since the mid-1990s. NPR quoted the co-chair of the steering committee for the Decadal Report, Robin Canup of the Southwest Research Institute. Canup also said, "We saw the mission as delivering absolutely transformative breakthrough science because we know so little about these systems. We are sure there are going to be lots of surprises once we get there." The next most abundant elements in the Sun after hydrogen and helium are oxygen, nitrogen, carbon, and sulfur, which make up a majority of Uranus's and Neptune's composition. 6 basic elements, carbon, hydrogen, oxygen, phosphorus, and sulfur, are used to create all living things. We will know if Uranus harbors the necessary remaining elements for the creation of life. once we manage to reach it, again for the most in-depth studies of the planet so far. While you may wonder whether or not any complex life can survive such harsh temperatures, there are animals on Earth that can live under triple-digit low temperatures, such as the Apis beetle. If found to harbor complex life forms, they are certainly to be those that we have never had any idea existed. Even if they are eventually found to be microscopic organisms, it would be a massive discovery nonetheless. Similar to Earth, Uranus has layers in its atmosphere based on pressure and temperature. However, the planet lacks a stable surface like the other gas giants. The area where atmospheric pressure is greater than 1 bar, or the pressure experienced at sea level on Earth, is referred to as the surface by scientists. Only 10 cloud patterns on the planet were noted by Voyager 2 during its 1986 flyby. As technology advanced, fainter clouds could be seen in images taken from Earth at higher resolutions. Winds as fast as 560 miles per hour carry the clouds, which are primarily found in its troposphere. According to experts, Uranus and Neptune are both amazing objects that provide the chance to learn about ice giants. The authors of the report ultimately concluded that Uranus should be NASA's primary focus. It is currently our best chance to find extraterrestrial life because it is a feasible, low-risk mission concept that could rely on currently available launch vehicles. The time required for any mission to an outer planet is still considerable. The National Academy's report recommends launching a mission to Uranus as early as 2031, but doing so would delay its arrival until the end of that decade. If the spacecraft arrived any later, it would be in the 2040s. If NASA chooses to follow the space science community's advice, the Uranus mission would entail placing a spacecraft in orbit around the planet and even launching a probe into its atmosphere. Therefore, it will undoubtedly take a very long time. According to preliminary estimates, the Uranus orbiter and probe mission will cost somewhere around $4.2 billion. According to some scientists, the only way to launch a mission to Uranus would be to use a more affordable concept that would cost less than $900 million. However, there will probably be 2 pieces of equipment, an atmospheric probe and an orbiting satellite. In contrast, NASA named its Cassini orbiter after the person who discovered Saturn's moons, and it studied Saturn from 1977 to 2017. The probe, built in Europe for the mission and named Huygens after the astronomer who confirmed Saturn has rings, landed on the strange moon Titan. The mission would seek to answer a number of other Uranus-related mysteries, in addition to looking for information that might clarify why ice giants are frequent around other stars. Why is the planet so cold, and why does its axis of rotation almost exactly fall into the plane of its orbit around the Sun, causing its north and south poles to be located where the equator is on most other planets? The launch proposal reported that suggests a 2024 launch also states that the Enceladus Orbit Lander mission, which aims to look for signs of life on Enceladus, the 6th largest moon of Saturn, should be NASA's top priority. The 2-year landed mission would study the fresh plume material coming from Eucydidus's interior ocean in great detail. The mission would also take place from orbit. Lastly, one of the most interesting benefits of this mission is enhanced planetary defense for Earth. Not with laser weapons, though, with intelligence. The report has an emphasis on planetary defense, or the effort to find and monitor objects like asteroids that could endanger life on Earth is one new area. It suggests putting more effort into improving NEO modeling and prediction and NEO detection tracking and characterization capabilities. By being able to study the gravitational properties of Uranus, NASA may be able to understand better what could cause asteroids to barrel straight towards Earth if it ever happens on a critical scale in the future. Let us know what you think about the possibilities of life on Uranus. Will it radically restructure our understanding of the universe, or would it not turn out to be much of a deal? Join the conversation in the comments below and subscribe to our channel for more regular space updates.